Okay, Trig, this will be the last video from me. Last time you got to see my ugly mug in the morning, okay? This is the last exam that we're going to be doing is this verifying trig identities. So we've covered this quite a bit already, so I just wanted to kind of wrap this up, show you a couple of my heavy hitters that you might see on the exam, okay? This is number 25 in your book in that homework section that I assigned. And, I picked this one because it's a good example of one of the tricks that I like to use, which is just to change everything into sines and cosines. So remember when we're verifying identities, we're trying to pick on one side and see how I stay on the left side the whole time until it looks like the right side. Okay, so we're trying to make one side look like the other. That's what establishing or verifying the identity is. So we're going to use our reciprocal identities here to switch tangent and cotangent into sine over cosine and cosine over sine, respectively. You'll notice, so there's the strategy. Anything that's not a sine or a cosine, write it in terms of sine and cosine. So that's what we did. So now on the left side, all I have is sines and cosines. Then I just distribute my cosine. It cancels out, squares on the top. Then I got this statement. Do a little common denominator fraction math. Then I see on the top when I do that, I get sine squared plus cosine squared, which is another identity, just equals 1. So I replace that with 1, and then 1 divided by sine is cosecant because of the reciprocal identity. Okay, so this would be a good example of, hey, one good strategy is to turn everything into sines and cosines and hope things start canceling out and simplifying down to where you want it to go. So it's a really good strategy when you're trying to build something that's pretty small, because what you're trying to do is cancel out sines and cosines. Okay, here's another example, number 77 in your textbook. This is a great example of when you should conjugate, use that property of difference of perfect squares. So I see two really gnarly sides going on here. Cosine cubed, ugh. And then, but I am going to pick the left side because I see a conjugate pair down here, right? Remember, the denominator is the thing that trips us up a lot of the times. So if I can mess with the denominator and make it better, that'd be great. So what I'm going to do is I'm going to take the difference of perfect squares by multiplying the bottom by its conjugate pair, that 1 plus sine. What that does is it gives me this difference of perfect square down here. I'm not going to distribute. Remember, resist the urge to distribute until you absolutely need to. Usually distributing makes things bigger, and our goal here is to shut it down, to make it smaller. Okay, so I see that didn't really help me much, So from there, I'm going to go with my Pythagorean identity. So that did help my bottom. And then I'm going to utilize that sine cosine trick. So change the bottom using Pythagorean's identity to cosine squared. Use a reciprocal identity to call this 1 over cosine. Then I'm going to distribute. I'm going to see that I have a common denominator up here. So I'm going to go ahead and add that up. And then I see that really I'm just dividing by two fractions. So I'm going to multiply by the reciprocal instead. And I'm going to multiply straight across to get to my identity. Okay, so remember the game here is it's just practice, try. Sometimes you'll see the trick right away and you're like, yeah, that was easy. Sometimes it takes several efforts. If you get stuck, just go back one step and maybe try something different. If you conjugated, maybe try the sine cosine thing. If you sine cosine, maybe you should conjugate. Remember, all the quadratic tricks are still here. Maybe factoring a quadratic's the way to go. Maybe building a new quadratic so that you can factor. Distributive property. Can you take something out to make it smaller? Things like that, okay? So this will be our last assignment. Just email me if you have any questions. But everything is due by the end of this Friday, okay? Everything but the final exam essay. All right, it's been a great semester, and keep going in mathematics. It's really an awesome thing. I'd love to see you guys take calculus. Thanks.